Thank you for joining my session. My name is Michal Brygidyn. I run a security department at PGS Software, but also I'm a white hat security researcher. And today I want to share my findings with you so that you can fix it in your projects. And I want to show you how small vulnerabilities may lead to a full cloud account takeover. Let's start with something simple, HTML. How to hack your cloud using HTML. That's very simple. Just look at the source code. And I don't know why, but there are many cases in which people just hard code credentials to their cloud in a source code, either in JavaScript or like here, in a comment for someone to remove later. But why do you hardcode it if you want it to be removed instead of putting it somewhere in documentation? So we have this source code, and this scenario is really simple because we just extracted valid AWS credentials from the source code, and hey, these were admin credentials because someone don't know how to configure their users, cloud users. And what went wrong here? Well, first of all, sensitive data in source code. There are many different ways to share a part of documentation with your team. You don't have to hard code it in your source code. You can just put it on Confluence or somewhere else if you want to say that there is a set of credentials to use on non-prod, on dev environments, something like that. Now let's move to something more complicated. Kubernetes. Who knows Kubernetes? Who is using Kubernetes? Nice. And how to hack your cloud using Kubernetes? It all starts with Kubernetes API. Like Philip mentioned on his presentation before, there are many built-in security features, and developers, I don't know why, but want to disable these features. And like here, there are many Kubernetes APIs available publicly in public subnets with public IPs, and role-based access control for them is disabled. This means that anyone can just connect to that API and ask for anything, like secrets, like config maps, like a list of pods with the configuration. Secrets are only base 64 encoded, so it's quite easy to decode them. And if you ask correctly, you can get something like that. A list of pods with a time, how long they are running, what state they are in. Config maps, so the config maps are just configuration files that are later pushed to containers. And secrets, simple secrets, username, password, etc. You can see that we already have S3 access and secret key on the secrets list. So this is our first this is our first way into the cloud. But it's only S3 access. S3 service is it's used to store files on AWS cloud, flat files. You can extract something interesting from these files, okay, but we are aiming for more. So what else I was able to extract from one of these Kubernetes secrets? Jenkins admin credentials. Jenkins is the automation server that you use to run your jobs, to build something, and there were credentials for admin user. So in the next step, I was trying to find a way to log into that Jenkins app, and there are two ways to log in. First of all, you can find a public endpoint for that Jenkins, like jenkins.example.com, and then using these credentials, you can log in. But sometimes companies hide these tools, like development tools, and there is no way to access them from the internet. But you already have access to Kubernetes cluster that runs this Jenkins. So you can easily forward port 8080 of that Jenkins Jenkins pod to your local host, and then you just simply open your browser and go to localhost on port 8080, and that's the same Jenkins application. So you can log into that Jenkins application. But what then? First of all, as admin, you have access everywhere. You can start digging in workspaces. If your job runs at least once, there is a source code for that job from the repository that that job depends on, and that source code is there available for you. So you can just see if there are any hard-coded credentials or something that you may use to dig deeper. In my scenario, there was a config file with another pair of access keys for AWS. This time I got access to SQSQ and Lambdas, and other services, but still not enough. Then, second place in Jenkins, it was in Jenkins credentials service. If you use Jenkins, you know that you can store your credentials in Jenkins credentials. But if you have more access to Jenkins, you also know that you can easily decode all these credentials. So I just took a look at the credentials list and found GitHub or GitLab credentials there. So after decoding, I had access to all repositories of that company. But also, I still didn't have access to full admin account on AWS. So the next step was to check build logs, console logs from different projects on Jenkins. And in one of these jobs, I noticed API calls for AWS using AWS CLI. This means that the pod that runs this job has access to AWS, either using hard-coded credentials or using a role. So I used kubectl exec to run bash on that pod, and thanks to that, I was able to run any command. And this pod had IAM role, AWS IAM role with admin access policy attached, and that was what I wanted to achieve, admin access on that account. But what went wrong here? First of all, public resources. Why Kubernetes APIs are public? I have no idea. These are not endpoints that should be accessible by customers, by your end customers. So if it's not something interesting for your customers, but just for developers, just hide it. Hide it behind a VPN. If there is a security feature, use it. Also, usually your production environments are covered by penetration tests, but many companies decide to exclude non-prod environments from pen tests to lower the bill for this penetration test. And these non-prod environments are exposed and sometimes vulnerable. Also, risky design. Maybe it's not that we don't know that it's public. Maybe we decided to make it public because we are a startup. We just started to develop anything, and we don't have VPN. It costs. So let's just make it public and hope nobody finds it. And then what else went wrong? Security features. If there is a role-based access control enabled by default, just use it. If you want to disable it, okay, but why? Sometimes the responses were, okay, but it's our cluster, it's a random IP. Who knows our random IP? It's only for our team to use. Nope, it's not. There are many search engines that scans the whole internet, all IPs and all ports on these IPs, and they record responses, they record banners from these ports. And when you create a new resource on the internet with new IP, it will be scanned in 2 minutes. So after 3 minutes, I will have access to it without making any noise in your infrastructure, because I will know that you have something vulnerable, and I can hit you right there. And what else? Encryption. If there is a way to encrypt sensitive data, just do it. And don't forget that base 64 is not an encryption. And yeah, so if you have to store your sensitive information in tools other than password managers or secret managers, be sure that these are encrypted. That way, if I get access to, for example, Kubernetes secrets, I don't get access to plain text credentials, but ciphertext, and I will not be able to decrypt it easily, or I will be. I will show later. And then firewalls, same as before. We have developers everywhere, different countries, and we are poor. We don't have VPN. We just want them to work for us, and that's why everything is in public. Why not? Okay, and then principle of least privilege. Very, very common scenario. Every single developer is admin in our tools because maybe one day they will need to do something more than just doing what they are usually doing. So yeah, let's give them admin access for everything because then they will not need to contact us for higher permissions. Then we have our CI/CD tools. We have these tools that we use to build our cloud. So these tools have full access to our cloud. They can create resources, they can manage resources, and delete resources. That's okay. But then why do we give admin access to these tools for our developers? If they are admins on our tool that is admin on our cloud, hey, what's the problem to deploy malicious resources and get the same access level? So yeah, if you have a tool with higher permissions, just be sure that your developers cannot exploit this tool. And yeah, last but not least, running apps as a root user, because yeah, my app sometimes needs access to different places, and it's easier to just give it a root user instead of setting correct permissions. But when I get access to that app, I am also doing anything as a root there, so I can install new library, I can install new app, I can get access to every single piece of information on that machine. Thank you. Then we are ready for the next scenario, Symfony Profiler. Who knows Symfony? Who works on Symfony? Okay. Symfony is a PHP framework. It's a really good framework with different versions, and every single version is vulnerable in its own way. And Profiler is a development tool used by PHP developers to see what's going on with their app. Usually it's turned on non-prod environments, and you can see different parameters of your application. You can see what's going on there. For example, you can check server parameters, environment variables used by the application, but you can also check all requests and parameters of all requests that your users are making in this application. This includes login requests with post-login requests with username and password. And some versions of Symfony also allows you to open any file in project structure. This can be parameters YAML file with all your other configs not available in server parameters on environment variables. But let's stick to our request history. But first, this is how it looks like if you open the Profiler tool. You can see that there are some environment variables, and we have our AWS keys already there, but these keys only allow you to access S3 again. But then I found a post request to a login endpoint with plain text login and password. Okay, let's use it. When I use that, of course, there's an endpoint defined for this request. I know where this request was made, and I was able to reuse login and password to log into that internal application of that company. It was admin account, because who else is using non-prod environments, non-prod apps? And it was, of course, dev environment. Okay, but dev environment had a dev subdomain. So instead of going to dev.example.com, I decided to use example.com and use the same login and password. And guess what? It worked. So I was in. It was an internal application, custom internal application, different features there, and there was a single sign-on page with different apps available for that user. There was a CRM, there was webmail, so I didn't need to access any customer data, so I decided to use the webmail to see what's there. On this webmail, I found a lot of AWS-related emails, like invoices, like trusted advisor reports, and this made me thinking that maybe this is a root user email for that AWS account. Why not? Let's check that. I tried to log in using that email, and I didn't have password, but I have access to that inbox. So why don't use reset password functionality? And guess what? It worked. I got my new password by clicking on the link that I got on that email, and I was in. Why? Because there was no MFA, so just login password and you're in. And this was really AWS root user, so I had full access to that account. There was no MFA, etc. But that wasn't the only nice thing there. It was the account used for the whole organization. It was organizational management account. So instead of getting access to one account, I got access to 40 or 50 different AWS accounts on admin level, because this root account was a trusted account for admin roles on all other accounts. Yeah, why not? So what went wrong here? First of all, production data on a non-production environment. It's a common scenario where a customer asks developers to find a bug somewhere, and they just copy the production database to a non-prod to work on a non-prod on a production data. But it's not a good idea, because then, first of all, you break many rules. GDPR doesn't like you, etc. But you also have your production data on a non-prod, which is not that secure, because you excluded it from pen tests. And if I get to a non-prod, then I can simply, using the same credentials, get to prod. So this is the second point here, reusing passwords for the same users on different environments. Even if you don't copy the whole database, you want to remember the same password, single password for all environments in this app. And the word remember is underlined here, because if you remember your password, it's already bad. Instead of remembering it, just keep it in a password manager. But if you have many different environments, your app runs on different environments, be sure to use different passwords on each environment. That way, if one leaks, it will only expose this environment and not the prod one. And sometimes I also found different architectures where prod and non-prod were running on the same cloud. Okay, it's easier to manage, and for small companies, it's better to have one account. That's how they were explaining themselves. But when you have both on a single account, and you have your non-prod not that secure, then getting into that account means that someone gets into your account with prod data. That's not good. And sharing email for different services. When I found this webmail, it was not only for AWS, but other services were also registered on that email. And it was Office 365 administration account. It was GitHub organization main account, because they wanted to have everything in a single place, to manage everything from a single place. And thanks to that, I got access to every single place. And also, sometimes companies try to explain themselves that this account is being used by different team members, and if someone goes on vacation, we want to be sure that others also have access to that. But hey, have you heard about distribution list instead of single inbox for that? Maybe you can use different. You can use different emails for different services, but then they can all point to one distribution list where you have your team members underneath. And also, it's a good idea to change your password from time to time, because if it leaks today, it will not be valid in 3 to 6 months, depends on your policy. And use MFA wherever possible. Why? Because if your password leaks, then I will try to use it. And if you have MFA enabled, then it will be a bit harder for me to use it. A bit harder because as one of the evil hackers group showed us recently, it's also not impossible to bypass MFA by, for example, finding where the guy whose password we got, where he lives. And we know that he lives, for example, in Poland, and we know that now in Poland there's 2 a.m. At night, and we will just push a lot of MFA requests to his phone. And if it's not on silent mode, it will ping and ping and ping and ping. And finally, he decides to press OK, allow. And that's how they bypassed a lot of MFA, multi-factor authentications, just because they bombed the MFA. Also, sometimes teams decide not to enable MFA because the account is being used by many people. It's a shared account, and that's a red light. If it's a shared account, just don't do that and create dedicated accounts for your developers. Now, the last one, the last scenario, it starts from GitHub. Who uses GitHub? Who uses public repositories on GitHub? Okay, let's start there. Public GitHub repositories. This can be the only step here, because if you look for different credentials, you can just get a lot of results with different credentials, not only AWS, but many different clouds, and you can just find it, grab it, and use it. But let's make it a bit more interesting. So for this scenario, I found a repository with interesting variable names, but the values for these variables were encrypted. Wow, someone used encryption in their hard-coded credentials in the file in the repository. Okay. So I decided to dig deeper into that repository to find a way to decrypt them. And then I found a Java class with the whole decryption logic. Okay, still not that bad, because you need a secret key to decrypt it. But it was hard-coded in the decryption class because it's easier. It's the only place where it's used, so yeah, why not? So I was able to decode these credentials, and I got access to Office 365 account. Here we can see different examples what to extract from public repositories. You can see different credentials for SMTP, for databases. Yeah, whatever you want, just pick one. And then how to proceed with that? We have access to Office 365 account. And using that, you can see what subscriptions are, or what plans are available for that user. And this user had all plans available. So for example, there was a TeamSpace API available. And this means that you can log in using that credentials to Teams. And on Teams, you can just find C-levels, for example, CEO, and say hi. And these accounts are usually service accounts, so the CEO will get a message from noreply@mycompany.com. Okay, hi. But that's not what we are looking for. We want to get access to cloud accounts, to other cloud accounts. So instead of just saying hello to a CEO, I decided to open SharePoint. And on SharePoint, I got access to many different files. And one of these files was a PDF file. And this PDF file was called a Jira installation guide or something like that. It was a step-by-step configuration guide that was created by some juniors to document what they were doing step by step to install the new Jira for the company. And the last step was, and now we created admin user with login and password. Okay, thank you. So I got login and password for admin user on Jira. And Jira, usually it is a public service, so jira.example.com, and voila, there was a login page for that. Thank you. And I was able to log in to that Jira, and as admin, I can access everything. So I looked for interesting projects, found few with AWS in name, and one of these projects had a task to create IAM user for external service. It was a vulnerability scanner or something like that. And this task had a comment, and in this comment, it was access and secret key in plain text. Someone finished that task by posting these credentials in a comment. So, yeah, thank you. I just grabbed these credentials and I'm admin on your cloud. What went wrong here? First of all, do not hard code any sensitive data into your source code. There are other better ways to store passwords, to store keys. You don't have to put them in your config files stored next to your classes, etc. And if you say that you don't use any secrets management tools, secret managers, password managers, etc., just start doing it because you need it. It's a bit safer. And if you encrypt something, be sure to keep the encryption key, the secret key, secure, and do not put it just next to the logic, because then there is no logic in that. And when you push something to the repository and you know that, oh, I shouldn't do that, it's okay, it's too late, then it's not enough just to overwrite it with a new version with some dummy value, because it's Git, it's version control. You can return to previous version, you can check Git history, and guess what? It's there. So instead of just overwriting it, be sure that your credentials are rotated, password is changed, keys invalidated, and it will not give any access to someone who finds it. Then we have bad tools selection. For this public GitHub repository, it was a support team working on Jira tickets. They decided to create some script that will reply to any new ticket in 10 minutes, because they had a SLA that they have to reply to every single ticket in 10 minutes. So instead of doing it manually, they decided to automate it. Okay, that's a great idea, but as they were not developers, they didn't know how developers work and where they store their code. So they created a free public repository and pushed everything there. And also, if you don't know how to share credentials in a secure way, for example, sharing it from your password manager, but you need to share your credentials because there is a new team member and you just created the account for him, it's not a good idea to share both login and password on the same channel, for example, on Teams or on Slack. Why? Imagine a situation where your new team member shares his screen right now because he presents something to customer or to other people from different projects. And instead of sharing just a single application window, he's sharing the whole screen. But he only shows what's there on part of the screen on one of the applications. And then on the rest of the screen, there's a Slack in background. Oops, sorry. There's a Slack in background. And when he's doing his presentation, you just send him the login and password, and it's there. Anyone on that call can just grab this and copy this and try to use it while he is presenting something. So instead of doing that, send one thing on Teams, one thing on email, or if you really need to use only a single channel, you can use a tool like a one-time, that's a web tool, where you generate a one-time link with your secret phrase, And be sure that the person you are sharing it with is focused on what you will just send to him just right now, and send the login and the link. Then he clicks the link, he gets the secret value, moves it to password manager, and if anyone clicks the link again or copies the link open in their window, it will be invalid because it's one-time link. And then we have lack of security awareness. That's the biggest problem everywhere, because usually developers don't know that something bad may happen if they use it that way or in other. So and not only developers, but in this case, we had a support team who had access to our AWS account to create a new user, and then they just decided to post this accessing secret key as a comment in this ticket. Okay, this was okay from their perspective because the ticket was done. We can move to another one, but it can be done a bit better. Instead of doing that, they can share it in a secure way, because the place that they're decided to use can be opened by not only the guy who created this ticket, but all other team members who have access to the same project. Also, if you create documentation, it's not a good idea to put valid user credentials in this documentation, because that's not required. It's not needed to be there. And I asked them why they did that, and they said that we were told to document every single step, and that was one of the steps, so we documented it. Okay, that's a nice explanation, but still, you can think before doing something that may be risky. And the last thing here, if you really have to send emails from your application, there are better ways than using your own directory user credentials. Because if you use your own Office 365 login and password just to send emails, then anyone with access to that repository will get your login and password, and they can log in as you to this service. Here it was Office 365, but it can be any other mailing service. And that's not really what you want. That was the last slide. Thank you for joining this session. Maybe you have questions. That's the right time to ask.
You were talking about the scenario where you managed to get the access to the webmail.
Mm-hmm. Mm-hmm.
How long it took the company to actually realize that the password was reset to someone?
Okay, the question is how long it took the company to realize that I changed the password for a cloud account. The thing is that when I find something, I report it to the data owner. It's not like I want to dig into your cloud account and then just maybe publish it or move on. I do it to find the way in, and then to tell the company, hey, you have a problem, there's a hole. So I told them immediately that when this was possible, the same night I shared the report with them saying that, hey, you have a big hole here, and the password is changed. So I don't know how long it would take, but there are other cases where I am completely ignored by these companies. So I still have valid access to different cloud accounts that I found in June or July. Still there, still working. So yeah.
Follow-up question.
Yep.
So would you suggest that there should be like some sort of alerts set up, like in the cloud?
Oh yeah, alerts. The question is if they should use some kind of alerts. Yes, and for example, the scenario with Kubernetes. You don't usually want your developers to log into these containers, and you don't want them to be there because they have everything streamed to the cloud. Logs are in different place. So if something appears in bash history or SSH log, then you can get a notification that something bad is going on, because usually they shouldn't do that. Also, if you use guard duty on AWS. It can scan your logs, your API calls on AWS, and it can find weird behavior. Because here in my scenario, I logged into Jenkins' machine to communicate with the cloud. And this was okay from the perspective of guard duty because I was still on that machine. But it's possible to extract temporary access and secret key from that machine and run it from my laptop. And then this will be successful as well, but it will be marked as something weird in guard duty. So you will get your notification that EC2 credentials were used outside of the EC2. And you can have automated responses to that, to block this this role, to remove that access, etc.
Okay, thank you.
If you have other questions, you can reach me on LinkedIn. I will try to answer every single one of your questions, future questions. Thank you.